Okay, y'all, we are on chapter 10.3. We're going to be looking at liquids and how the kinetic molecular theory applies to liquids.
That one.
On this lesson, we're just going to talk through it. So, guys, you could just read through the PowerPoint and hopefully take your notes, but I'm going to do it with you. Alright, liquids are described as any form of matter. It has a definite volume and takes the shape of its container. So you have definite volume but indefinite shape. In a liquid, there are more attractive forces between particles than in a gas. This is because the particles are moving slower and more intermolecular forces can hold the substance together. The particles are not bound in fixed position, but they are moving about at a slower rate than the gas. Liquids and gases are both fluids. Liquids and gases are both fluids because they can, flow. I can pour liquids out of things, and I can pour gases out. Both of them will take the shape of its container or have indefinite shape. Here's some basic properties of liquids. You have high density, which means that versus a gas of the same substance, the liquid is going to rest lower in a column. Okay? They're much more dense in the liquid state. Now, liquids are also much less compressible than gases, meaning you can't squish them together because the particles are already close together. Now, just like gases, liquids can diffuse or mix in with each other. They will go all the way through anything they can dissolve in. Polar can dissolve in polar. Nonpolar can dissolve in nonpolar. Okay.
Liquid.
The last one we're going to talk about is viscosity, the measure of a liquid's resistance to flow, or how quickly or slowly something can be poured out. Liquids with stronger intermolecular forces are very viscous. And the higher the viscosity, the more slowly it flows. This is temperature dependent. Think of syrup, guys. Syrup flows very slowly, but when you get the hot syrup at, say, IHOP or Cracker Barrel, it flows a little faster than it normally would. So just keep that in mind. Down here I've got 4 motor oils, different grades. Can you tell which one would be most viscous versus least? Hopefully you saw that the one on the right is the most viscous. That ball bearing is slower, very slow at flowing through it, whereas the 20 version is very, very fast. Alright, we're going to talk about cohesion and adhesion. Cohesive forces are the intermolecular forces like we talked about with the hydrogen bonding and London dispersion forces and the dipole-dipole forces, last section. Cohesion and adhesion, cohesion talks about those 3, whereas adhesion is the forces between the liquid and its container. So right here, what kind of forces holds the liquid in the container or keeps it attached to it? Now, if you look here on the right, we've got mercury. So that shows you that the cohesion is very strong. It wants to hold tight together, and it forms this little bump up. Whereas here at the water, it would rather attach to the container, forming a meniscus. And that's why it looks like it rests a little lower. It's more attracted to the container than it is itself. Which is pretty interesting considering what we know about intermolecular forces. The last thing I want to talk about with properties of liquid is surface tension. This is the force that holds adjacent parts of a liquid surface together and decreases surface area. So this is what kind of holds, if I were to take a penny and to drop the water droplets onto it, I could fit a bunch of water droplets on one penny because the surface tension holds it all together and it bubbles up. Or like the penny example from before, where we can continue to put pennies in a very full cup because the surface tension will hold. Here you can see surface tension causes droplets to take on a spherical shape because it encloses itself. And it also helps objects prevent from sinking, like water bugs that walk on water or paper clips resting on water, which you can try that one again.
Bug.
The higher the attraction between the particles of liquid, or the more intermolecular forces, the higher the surface tension. So thinking about water, it has a very high surface tension, and this is because it has what? What intermolecular force does water have?
Juice.
Not juice. It has hydrogen bonding.
Oh, I don't know that.
I know. Shh. All right, excuse Asher. Guys, if you will, please make sure you work on homework set 10-3. Honors and standard, double check the calendar and see what I put on there as to whether you do all or odd. Thanks, guys.